Okay, hi everybody. This is the part 2 for the Math 70 final exam review. These are some random problems that were given to me at our last class. So we left off on number 80. It says solve e raised to the 3x minus 7 power equal to 6. Find the exact solution and approximate the solution to 4 decimal places. We're going to start off by taking the natural log of both sides here. Okay, now because we have a logarithm here, we can use our logarithm property. Since we have e raised to the 3x minus 7, I can bring that 3x minus 7 out in front and multiply it to the front of this logarithm or natural log of e. Now if you recall, natural log of e means the same thing as the logarithm base e of e. So I'm just going to go ahead and write that log base e of e. And that just means e raised to what power is equal to e. So that's just 1. Alright, so this just actually means 3x minus 7 times 1 is equal to the natural log of 6. So anything times 1 is just going to stay the same. So I'll just copy down to 3x minus 7 equal to the natural log of 6. And now we can solve for x. Alright, so we're going to add 7 to both sides. And that's going to leave us with 3x equal to 7 plus the natural log of 6. Now I'm going to divide both sides by 3 to isolate the x. And the 3's are going to cancel out. And we'll just be left here with x is equal to 7 plus the natural log of 6 all over 3. This represents my exact solution. Okay, now we need to get the approximation. To get the approximation, I'm going to use my calculator. I'm going to have to input this. So in order to input this, we're going to have to use some parentheses. I'm going to open a set of parentheses. Oh, I accidentally put the 7. Let me take that off. Wait, let me go back. Let me clear this. I'm going to open a set of parentheses to show that everything here is in the numerator. The 7 plus the natural log of 6. I'm going to close the set of parentheses for the 6 that's inside the natural logarithm, and then I'm going to close another set of parentheses for what's in the numerator, and then I'm going to put divided by 3. Enter, and we get 2.9305869. We're going to round to 4 decimal places. In order to round to 4 decimal places, I'm going to have to look here. 4 decimal places would be the 5, but since we have an 8 next to it, we're going to round that up to a 6. So that's going to be 2.9306, and that's going to be our approximation. And we're done. That's it for that problem. Let's go on to the next one. The next problem is number 81. It says find the distance between the points. There's three parts. There's three sets of points here. So we're going to find the distance by using the distance formula. So I just kind of copied that down. This is derived from the Pythagorean theorem. I think I have a video on the distance formula. If you'd like to see how we come up with this formula, you can refer to that video. I'm going to start off with A. I'm going to label my points. X sub 1, y sub 1, x sub 2, y sub 2. And I'm going to substitute into the formula. So we're going to have here, no, not negative. I meant 3 minus 5 quantity squared plus negative 4 minus 4 quantity squared. Three minus 5 is negative 2, and we're going to square that. Negative 4 minus 4 is negative 8, and we're going to square that. This is going to be 4 plus 64, which is just going to come out to the square root of 68. We can simplify this a little bit. So what I'm going to do is I'm going to create a little factor tree. I'm going to come up here with two numbers that give me 68 if I multiply. So those two numbers would be 2 times 34. And then I can factor 34 out more because it's not prime. So that's 2 times 17. I'm going to cross out the 34. So I've got the prime factorization here of 68. I see I have a pair of 2's. So I can take that out as a single 2 out of the square root. And inside the square root, we're just going to have left over the 17. So 2 square roots of 17, or 2 radical 17. Okay, let's go on to part B. I'm just going to go ahead and move this over a little bit. Alright, so our 2 points are 5 comma negative 3 and negative 2 comma 8. And I'm going to label them x sub 1, y sub 1, and x sub 2, y sub 2. And I'm going to substitute those into the distance formula. So we get 5 minus negative 2 quantity squared plus negative 3 minus 8 quantity squared. Okay, so when you have minus and negative, we can rewrite that as a plus. So I'm going to rewrite that. So that's going to be 5 plus 2 quantity squared plus negative 3 minus 8 is negative 11, and that's squared. And when we add 5 plus 2, that's just going to give us 7. And then we're going to square that. And 11 squared, oh sorry, negative 11 squared is 121. 7 squared is just going to give me 49. And 49 plus 121, let me work that out and make sure I don't make any mistakes here. Okay, so I got 170. Now let me factor out 170 just to make sure that there are no perfect squares inside 170. 170 is 17 times 10, and 10 is 2 times 5. The prime factorization of 170 is 2 times 5 times 17, and there are no perfect squares in there. Therefore, this is already simplified, so I'm just going to leave this as a square root of 170, or a radical 170. I'm going to box in my answer. All right, we're ready to go on to part C. I don't have a lot of space here, so let me see if I can fix this. That's better. C is C is going to be 7 comma 10 and 7 comma negative 3. So let's label these x sub 1, y sub 1, x sub 2, y sub 2, and let's substitute into the formula. Okay, so we're going to have inside the square root 7 minus 7 quantity squared plus 10 minus a negative 3 quantity squared. That looks like an equal sign. Let me fix that. So 7 minus 7 is 0, and that's going to get squared, but that's just 0. And that's going to turn into 10 plus 3 quantity squared. So this is just going to give me the square root of 13 squared. And this 13 squared is 169. You don't actually have to square the 13. If you can already tell that it's a perfect square, you can go straight to taking the square root. But you could square it if you want, and then you could factor it, and then you'd see that it has two factors of 13. So the square root of 169 would just be, 13, just 13. All right, so that's the final answer for that one. That was number 81, finding the distance between 2 points. Let's go back to the next problem. 89. I'm just going to do A here to make sure that I don't go over my time limit for my videos. I'll do part B and part C on another video. So 89 says solve and then write the solution as an ordered pair. I'm going to substitute the 3x minus 5 that I have here equal to y into this y squared. Okay, this is a nonlinear system of equations. I can already tell that one of them is a line and the other one is a circle. So I could tell that it would probably have at most two solutions, possibly one, maybe none. We'll see. This is what I get when I substitute. Alright, now we have to square this binomial. So that's going to be 3x minus 5 times another 3x minus 5. You're going to have to FOIL this out just to make sure I don't make any mistakes. I'm going to work this out right here on the side. I like to use the box method when multiplying polynomials. It keeps me nice, neat, and organized. 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. Negative 5 times 3x is negative 15x. And negative 5 times negative 5 is positive 25. And then I can combine some like terms here. Negative 15x plus negative 15x, that's going to give me negative 30x. So when I write that out, I'm going to make sure I write negative 30x. So 9x squared minus 30x plus 25 equals 5. I've got some more like terms I can combine here. These x squareds can be combined. Oh, I could also move this negative 5 over. Sorry, it's positive 5, and I'm moving it as a negative. The reason I'm moving it over is because I have a quadratic equation. And whenever you have a quadratic equation, your goal is to set it equal to 0 and then solve it. Oops, I forgot the x on that 30. Let me go back. So your first goal here would be to factor. If the quadratic equation that you come up here with is not factorable, then you should try using the quadratic formula or completing the square. Fortunately for us, this is factorable, so we do not have to use the quadratic formula or completing the square. I'm going to set each one of these factors equal to 0 to solve for x. So I get x equal to 2, x equal to 1. Now we're not done because our solution has to be an ordered pair. I'm going to have to go back and I'm going to have to substitute to find that ordered pair. Alright, so what I'm doing here is I'm substituting x equal to 2 into the first equation, y equal to 3x minus 5, and I'm substituting to there because this equation is already solved for y, and that's the value we're missing is y. So I end up with y equal to 1. So our first ordered pair is going to be 2 comma 1. Now we need to find our second ordered pair. So now I'm going to substitute x equal to 1 into that same equation. So we're going to get y equals 3x minus 5, but instead of x, we're going to substitute 1. So that's going to give me y equals 3 times 1 minus 5. So that's going to be y equals 3 minus 5, which gives me negative 2. And we came up with another ordered pair. So let's go ahead and write that ordered pair down. That's going to be 1, comma, negative 2. And we came up with our two solutions for the system of nonlinear equations. Okay, that's it for this problem. I'm going to do another video, a third video, I guess, for this, the rest of the problems I haven't done. All right? All right, thanks.